When working with negative exponents, it's important to remember this. When moving exponents from the numerator to the denominator, or vice versa, you change the sign on the exponent. So if we have a negative exponent in the numerator, we can move it down to the denominator and make it a positive exponent. That's how we work with negative exponents. We get rid of them by changing them into positives. So if we look at this rule here, a to the negative nth power, we can always think of something that's like that over 1. If it's not in fraction form, you can always put it over 1. That helps us see that to eliminate the negative with the exponent, we need to move it down to the denominator to make it positive, a to the nth power. When we move it down here, there's nothing left up on the top. You can't have a fraction without a numerator. So what we do is we fill that space with a 1. So we simplify that to 1 over a to the nth power. Usually directions to these kind of problems will tell us to write our answer without negative exponents. This is how we get rid of those negative exponents. So let's apply that to some problems now. X to the 0 power times a to the negative 5th power. We've learned that x to the 0 power is equal to 1. Anything raised to the 0 power is just 1. Now I'm going to think of this as a fraction over 1, because that helps me see that a to the negative 5th power is in the numerator. In order to make that a to the positive 5th power, I'm going to move it to the denominator. I still have the 1 on the top. Even if I didn't, I would have to fill that space with a 1. So the answer to this problem, 1 divided by a to the 5th power. The directions for these kind of problems would say something like, write your answer using only positive exponents. In this next problem, I'm going to start by thinking of it as a fraction, and I'm only going to move the parts that have a negative exponent on them. We have to separate the 4 from the x and from the y. So the number 4 does not have a negative exponent, so it stays on top. X to the negative 4th has a negative exponent, so I move it to the bottom to make it positive. Y to the 3rd is already a positive exponent, so it stays on the top. 4y to the 3rd power divided by x to the 4th power would be our answer. In this last one, write it like a fraction, so I can see that everything's on top right now. A to the negative 9th power, I'm going to move to the bottom, so it becomes a to the positive 9th power. B to the 5th power, 5 is already positive, so I'm going to leave it on the top. B to the 5th power divided by a to the 9th power. Let's look at a few more examples of how we work with negative exponents. In this problem, we have 5 to the negative 8th power times 5 to the negative 7th power. I'm going to write that over 1. So in order to get rid of those negative exponents, what I'm choosing to do first is to get rid of them. You could add them together and then get rid of the negative, but I've noticed that it helps, I think, more students make less mistakes if we eliminate the negatives first. So we're going to change this to both those powers by putting them on the bottom in the denominator, and by doing that, the negative exponents become positives. Now there's nothing left on top, so I have to put a 1 up there. Now I have left the step to combine those 5s. We don't want to have two powers that have the same base in our answer. So we leave a 1 on top. We'd never multiply 5 times 5. We leave our base 5, and we add the exponents, because the rule is for multiplying with powers, if they have the same base, we add the exponents together. So we end up with 1 over 5 to the 15th power. This problem right here with the a's, I'm going to start out by making it a fraction. Anything that has a negative exponent, I'm going to get rid of that by moving it down to the bottom. And so this becomes a to the positive 2nd power. I'm going to leave a to the 10th power on top because it's already positive. We don't want to move it if it's already positive. So now we can picture this. There's 10 a's on top, 2 on the bottom. We could just subtract the exponents and get 8. A to the 8th power is the answer. Or we can picture 10 a's on top, 2 a's on bottom. The 2 on the bottom are going to cancel out with 2 on the top, and we're left with 8 a's on the top and nothing on the bottom. We can write this over 1, but more simplified, we would just need to say it's a to the 8th power. You don't need to put it over 1. In this example, with the 7s, we could start by subtracting the exponents because we are dividing powers that have the same base. We could start by taking 2 minus a negative 8. We have to be really careful that we don't forget a negative and just do 2 minus 8. 2 minus a negative 8 is 2 plus 8, which is 10. So I would end up with 7 to the 10th power. And that is the correct answer. Now, another way that I have shown people to do this that I think helps eliminate problems with negatives is let's get rid of the negative first. Let's bring that up to the top and make that 7 to the positive 8th power. So now it's not on the bottom, it's on the top. My base stays the same, never multiply the bases, and 2 plus 8 is 10, the same answer we got by subtracting the exponents. Either way, we should end up with 7 to the 10th power. In this last example, I'm going to do this the same way I did the previous problem. I'm going to eliminate that negative exponent by bringing it up to the top. And it turns into k to the positive 9th power. So now we don't have a denominator anymore. We don't need to put anything there. We could write over 1, but we don't need to do that. There are no numbers to multiply the 5 by, so we leave it a 5. I have two k's, two different k terms that I'm multiplying together. So I leave the base k, and I add 3 plus 9, and I get an exponent of 12. 5k to the 12th power.